All right, so in this video, we're going to be talking a little bit about the binomial theorem, just so that we have some strategies for dealing with our multiplicity functions that are higher than squared, which we've encountered the square of the binomial process foiling way back when, but when we have to deal with x minus c cubed or x minus c to the fourth, and other kinds of multiplicities, we want to multiply out the polynomial. We certainly can apply the foiling process, but it's super tedious. And so for these kinds of problems, I just want to introduce sort of briefly a trick that you can use called the binomial theorem. Now, this is a theorem that also shows up basically when you're doing probability and statistics as well. Some form related to this shows up, the binomial probability distribution. But for our purposes, we're going to be using it to do foiling of binomials raised to integer powers, positive integer powers. So let's break this down. So let's say I want to raise, I would have to multiply out this binomial expression, but I want to raise it to the second or the third or the fourth or the fifth power or more, some n number of times. The formula here is I'm going to sum up a whole bunch of terms. I'm starting counting with I equals 0. So this first power pair of powers, a and b, they're going to be a to the n, whatever my top n is, minus I, which in this case, starting at 0 would be a to the n, and then b to the 0. So no b. So a to the n would be the first coefficient, the first polynomial term. And then the second term would be 1 down from n on the a and 1 up on the b. And you would keep doing this. So if we're starting at 5, we would have a cubed, a to the fifth first, and then we would have a to the fourth times b, and a cubed and b squared, and then a squared and b cubed, and a times b to the fourth, and then finally b to the fifth. So the powers always add to 5, but you start with high a and no b, and you work your way down, increasing b, decreasing a, until you get all the way to your biggest b. And then this number out here, this is read n choose I. This is a combination formula, and it basically tells you what the sign of the size of the coefficient is going to be. So any number choose 0 is going to be 1. And any number choose n itself is also going to be 1. Any number choose 1 is going to be the number, n in this case. And any number choose n minus 1, so 1 less than that, is also going to be that original number. Where things get more complicated is when you go into the middle. And those coefficients, they depend on a formula, or you can find them using Pascal's triangle. So the formula requires factorials. So ni is going to be given by n factorial divided by n minus I factorial and I factorial. Now, the factorial stands for n times itself and times every number less than that down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And so this was a product of things. A bunch of stuff is going to cancel. You usually get, especially for reasonable size n, usually get a reasonable size coefficient. The ones that where I is in the middle of 0 through n are going to be the largest. But this is not the only way that you can calculate it. There is a key in your calculator that you can use. They call it NCR because they use R instead of I. This notation is consistent with this formula, and you will sometimes also see n comma I depending on which technology you're using. But but it's a combinations formula. Now, the way that Pascal's triangle will work for this, and this is usually for small values, sort of the quickest way to get there if you're not familiar with factorials. We're just going to build a small one just to show the top values. So the Pascal's triangle starts with 1, and this is essentially the top row is equivalent to n equals 0. There's only one way to organize no items, and that is not at all. Now, when you get to n equals 1, you go down 1, and both ends of every row are always going to be 1. So this side right here, this is equivalent to n choose 0, always on the one side. And on this side, it's always going to be n choose n. So here we have 1 choose 0 and 1 choose 1. If you have one item, there's only one way to organize it, which is the one way, because there's only one thing. You either have nothing in the list, so there's only one way to do that, or you have one thing in the list and there's only one way to do that. Kind of boring, but this is the foundation. Now on the next row, again, we have n equal 2. There's 3 things that we can do. So there's no things, one thing, or 2 things. So no things and 2 things is everything. What happens in the middle? Well, to get the middle term, we add the 2 terms above it, and we get 2. So these are the coefficients you would have in your perfect square binomial formula, 1a squared plus 2ab plus 1b squared. Now, if you go down to the next line, n equals 3, then again, we have 1s on the outside. And then when we add, we get 3. 1 and 2 is 3. 2 and 1 is also 3. So our cube, a plus b cubed, will be a cubed plus 3a squared b plus 3ab squared plus b cubed. For n equals 4, again, 1 on the outsides. And then 4 is 3 and 1, 3 and 1. But in the middle, we have 6. N equals 5. Again, 1 on the outside. And then 5. Notice this is always equal to n. 4 and 1, 5. But in the middle, we have 10 and 10. And then I'll just do one more. We almost never go this high when we're doing binomials, but for the sake of completeness, 6 and choose 1, and choose 5, 6 choose 5, 6 and 6. Add these together, we get 15. And again, we get 15. This is 6 choose 2 or 6 choose 4. And then this is 20, 6 choose 3. Always the one that's in the middle is the one that gives us the biggest coefficients. Now, this is going to allow us to multiply out relatively quickly. And what I'll do is I'll do an example, let's say with the 4th power, just so we can see that, yes, we do in fact get these coefficients. And then we'll apply the theorem for n equal 5. And then you can check that if you want by multiplying our 4th degree term that we get by our one more factor. And then you can verify that you get those coefficients. So let's do our a plus b to the 4th. And we're going to do it by multiplying everything out. So I'm going to separate these into a plus b squared and a plus b squared. Now a plus b squared, again, this is something we learned way back in, 9th grade or whatever. So a squared plus 2ab plus b squared. and a squared plus 2ab plus b squared. And again, you can recreate it by just foiling a plus b times a plus b, or using our binomial theorem up here. And then we need to FOIL out these two terms. So a squared times a squared is a to the fourth. A squared times 2ab is 2a cubed b. And a squared times b squared is a squared b squared. And then 2ab times a squared is 2a cubed b. And then 2ab times 2ab is 4a squared b squared. And then 2ab times b squared is 2ab cubed. And then b squared times a squared is a squared b squared. And b squared times 2ab is 2ab cubed. And b squared times b squared is b to the fourth. And when we combine like terms, we get a to the fourth. Here's 2a cubed b. And I think I have a typo right here. Let me double check. A squared times that's a to the fourth. And this is a squared times b squared. That one's fine. AB times a, yeah, this one is a cube. It's 2ab times a squared. So that'll be 3a's. All right, so then that gives me plus 4a cubed b. And then my a squared b squares will be the next one down. So there's 1 there, there's 4 there, and there's 1 there. So that's 6a squared b squared. And then I need b cubes. 2ab cubed and 2ab cubed is 4ab cubed. And then there's only 1b to the fourth. So this is exactly what we expected to get. 1, 4, 6, 4, 1. Now, if we wanted to do minus signs, the thing that we just have to keep in mind is that the leading term is going to be positive and the signs flip after that. So the formula is basically the same. You can treat b in the formula as minus b, and then the odd powers will be negative for b. So again, but we're going to use our thing here, our Pascal's triangle. So a to the fifth minus 5a to the fourth b, that's 1 power of b, and so the sign is negative. Then we flip again, 10a cubed b squared. So b is positive, so it's back to positive again. And then 10a squared b cubed, but that was going to be negative because b is odd. And then plus 5ab to the fourth, so back to positive because b is an even power, and then minus b to the fifth. So again, you could, if you wanted to verify, you could redo this with a minus b. So you would flip all these, flip this sign, flip that sign, and then multiply by a minus b 1 more time. And you should get exactly this answer. And it should be exactly the coefficients you have up here. Now, where you need to be a little bit careful is if b is a number, then you have to deal with these constants these coefficients are going to change. I would recommend applying the formula, writing the number 2, like if it's x minus 2, write it out as 2 squared and then simplify the coefficients. Because sometimes if you try to do it in your head, as I have tried to do on a couple of other videos, sometimes you'll forget that the constant is affecting the coefficient out front, and that's embarrassing. But you want to make sure that you get it right. And so writing it out in stages is, especially when you're not accustomed to doing it all the time, it'll be more reliable if you write it out with the constant in place of b and then simplify the coefficients after that.